Alright, today we're going over complex ions. Some helpful hints on if they're complex is if the problem says it's in excess, it's in concentrated, if it's excess concentrated, excess saturated, or when it tells you it's a complex ion. Complex ions are species where the transition metal ion is surrounded by a certain number of ligands. A ligand is a molecule or ion that behave as Lewis bases. If you have a transition metal as a reactant plus a ligand, the product will most likely be complex ions. And the product is a transition metal connected to a ligand, where X is twice as many as the charge on the transition metal, and Y is the charge based on the likely charges inside the brackets. And these are some ligands, so if you see them in a problem, it's most likely a complex ion.
So an example problem would be this one. Excess hydrochloric acid is added to a solution of cobalt-2 nitrate to produce a coordination complex. Cobalt, in this case, would be the transition metal, and nitrate would be the ligand, since it was on the list. And okay, so the HC, you would set it up as a normal net ionic problem. Would it be HCl, CO, NO3. CO originally had a charge of +2, and NO3 had a -1, so the charges flip-flop. H would pair up with NO3, and CO would pair up with ClO2. Since Cl is a ligand and CO is a transition metal, you would pair them up to make the coordination complex. Okay, and then since HCl is a strong acid, it breaks into ions, would be H plus Cl minus. And since in the problem it said a solution of cobalt-2 nitrate, it would also split up. And since COCl4 with the 2 minus charge, that occurs because CO is a transition metal, ClO4 is the ligand. 4 would be considered the X, where originally the +2 becomes 4 because X is twice as much. And Y is the charge, so you take +2 minus 4 becomes -2. And then since HNO3 is a strong acid, you would also have to split it up. It becomes H plus minus NO3. So then, since we're going to keep the complex ion, when you break everything down, H plus, Cl minus, CO2 plus, NO3 minus, you need something, considering since it broke up over there, to balance the complex ion, and that would be the H plus, because you need something positive and negative to balance. Since there was a -2 charge, there'd be a +2 charge over here. Since the end, you only need the ClO4. You would keep the Cl and the CO2 plus, and in the end, this would be your answer. Once you balance the equation, it would be 4Cl, 1 CO2 plus, and then the coordination complex itself. And this was done by Sam Franz, Melissa De La Rosa, Osmar Martinez, and Veronica Zamora.